Okay, we're back on 2-3, and we're talking about rates of change, velocity, and marginals. And we're still working on velocities. We're looking at average velocity, and we left off with that question, discuss the sign of the average velocity, and why does it have that sign? It's because the object is moving downward, okay? And generally, gravity, as it pulls you down, that's considered the negative direction, and the positive direction is, of course, going upward. But we can talk more about that. That's not a biggie. So, instantaneous rate of change, velocity. We have the instantaneous rate of change, or simply rate of change of y is equal to f of x at x, is the limit of the average rate of change on the interval from x to x plus delta x. And remember, that's just like saying if the limit was going from 2 to 5, those are x values. We're just saying that there's an x value. There's an x value somewhere on a number line, picture it. Here's an x, and then delta x down the road, there's another x value, but we're going to call it x plus whatever delta x is. It just happens to be the distance that we traverse from x to x plus delta x is delta x. So we take the limit as delta x approaches 0 of that difference quotient that we've talked about before. Okay, and sometimes you just have to be a little patient with this, because what happens is that this part is what's sometimes a little daunting for people. So once you get that off to the side, bring it back, subtract f of x, and then divide it by delta x. It's a lot easier. So if y is a distance and x is time, then the rate of change is a velocity. So now the derivative can be interpreted as the slope of the graph, or the instantaneous rate of change, such as ds dt, the change in position over the change in time. So what we're going to look at first in example 3 is finding an instantaneous rate of change. Find the velocity of the object in example 2 at time t equals 1. Exactly time t equals 1. So what we want to do is take the derivative. So we have s prime. My first step is s prime is equal to negative 32t. And then we want to find it at 1, so we're going to plug in 1. And I'm going to use functional notation with that. I'm going to say s prime of 1 is then equal to negative 32 times 1, which is equal to negative 32. And we would just give our answer then in the proper units, which would be feet per second, negative 32 feet per second. Now, what I like about the Lagrange notation ds dt is it always kind of reminds you, oh, what are the units? Oh, that's right, it's feet per second. So if you ever get into finding your final answer and you're wondering what are the units, sometimes that the Leibniz notation, I might have said Lagrange, it's Leibniz notation. It's actually convenient to think about what the units are. Okay, so there we go on that. And moving on. So if we consider this, you're going to see these equations a lot, and they're quadratics, where they're written as negative 16t squared plus v sub 0 t. You have to insert this t plus s sub 0. Then if you think about it, a is equal to negative 16. That's half of gravity, which is 32 feet per second squared. And v sub 0 is initial velocity, and s sub 0 is initial position. So just because it's going to come about fairly often in mathematics and calculus and physics. So there you have it. And there it is. And let's do the problem now. Finding the velocity of a diver. At time t equals 0, a diver jumps from a diving board that is 32 feet high, as shown below. The diver's initial velocity is 16 feet per second. So the position of the diver is given by the equation you see there. S is equal to negative 16t squared plus 16t plus 32. So the first question is, when does the diver hit the water? Generally, as a principle of charity, we kind of accept that the ground level has a height of 0, or we're at a 0 level. So we would say then 0 is equal to negative 16t squared plus 16t plus 32. And then in solving that, we could factor out a 16 or a negative 16 to be left with t squared minus t, and then minus 2. So factoring that further, negative 16, I'll leave it there, t minus 2, t plus 1 should be the factoring. So we have at time t is equal to negative 1, or t is equal to 2. I'm going to just make this a little smaller. So we have if t minus 2 is equal to 1, equals 0, or t plus 1 is equal to 0. So we get when t is equal to 2 or negative 1 seconds. So, and we look at the negative 1 and we kind of like say, oh, well, that's extraneous. So we're going to take that away because it doesn't make any sense to go back negative seconds, right? So in 2 seconds, okay? So well, the solution t equals 1 doesn't make sense in the problem because it would mean that the diver hits the water 1 second before he even jumps. Boom. So what is the diver's velocity at impact then? Well, now you know when the diver hits the water. So all we have to do we have to say then s prime of 2, which is negative 32 times 2 plus 16. And then we get a final value of negative 48 feet per second. And there you have it. There it is. There you go. So I'm going to finish for right now, and you guys can look ahead at the rates of change in economics, and that will be the third video for section 2.3. Take care now.